Okay, so I have a very interesting problem here. Very interesting math puzzle. So I have three slots over here. You can think of it as a car park or something. So this is the first slot number one, and then this is slot number two, and then this is the third slot number three. Okay, so we have three slots. And then now we have three people, A, B, and C. Okay, you can think of them as people or letters or whatever makes it easier to imagine. Uh, okay, so now it's three people. Okay, A, B, and C. All right. So here are here are the rules of the game. The first rule is that each slot can contain any any number of people. All right, any number of people. All right, so the first slot can contain no one, right? Zero, there's no one in slot number one, or it could contain A, all right, or it could contain A, B, C, all right. It could contain everyone, but then it would mean that the remaining slots would have no one. All right, all right. So each slot can contain anyone, yeah, any number, any amount of people. Okay, the next rule is that uh, any any person must be allocated to some slot. Okay, so you cannot leave them out. They have to be like A or B or C has to be in some location, some slot. Okay, they have to be included. All right. So those are the only two rules. Now, what's the question? Question is how many let's say how many arrangements, right? Arrangements are there. All right. So what do I mean by arrangement? So for example, uh, let's say for the first arrangement, you can have A in slot one, B in slot two, and C in slot three. Okay, and another arrangement could be A B in slot one, no one's in slot two, and C in slot number three. Okay, that's another arrangement. Okay, so the answer to this particular scenario is 10. Okay, so here's the answer. So there will be there's a total of 10 microstates. Okay, microstates or arrangements. All right, arrangements. I can't spell. All right, all right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, total of 10 microstates or arrangements, and each row is a microstate. All right. So, for example, in this particular row, everyone is in slot number one, right? The remaining slots have no one. And let's say in this scenario, okay, one person is in slot number one, and the remaining two people are in slot number three. And I think I forgot to mention order does not matter. All right, I forgot to mention. I'll include a note here that order it it does it does not matter. Does not matter. What does what does that mean? It means that ABC. Let's say you have ABC in slot number one. In slot number one is the same as BAC in slot number one. All right, it doesn't matter. Okay, we only care about combinations here. Okay, combinations. Okay, so now that we know how this works, the main question is that if I have n n slots and q people, all right, then what would be the formula uh in the form of combinatorics, right? The one we learned in high school if you're a ninth grader, uh which is like this in this form: C choose N, like that, right? C choose N, or or 6 choose 2, in that form, basically. Yeah. So how do you come up with that? And I will show the answer in any moment. So before I show the answer, I want you to look at these four scenarios and tell the the differences and the similarities. So here I have four different microstates. Okay. In the first microstate, we have AB in slot 1, C in slot 2. In this microstate, A in slot 1, B, C in slot 2. Okay. They kind of vary from each microstate to another, but the similarity here is that it's I should say is that which person belongs in which slot. That might sound a bit confusing, but here you can see in this microstate, B is between A and C. All right, B is between A and C, but B is in slot 1. All right, and in this microstate, B is also between A and C, but B is in slot 2 now. All right, so how do you make that distinction? All right, how do you make the distinction? And here, B is in slot 3, between A and C. All right, so this is where this is the perfect solution for this one. What you really want to focus on is, I should say, the partition line. Now, what is a partition line? It's these barriers right here. All right, maybe I should. These are the partitions line. Okay, so these line. Okay, now I don't want to delete that. So these lines are the partition lines. All right. Why are they called partition lines? I think it's because they separate the slots. They separate the slots, and that's it. And I think the best way to solve this puzzle is to somehow get rid of those partition lines. We don't want the partition lines, the barriers between the slots, because they kind of make everything confusing. So turn what if I turn these partition lines into slots? All right, that might sound a little bit crazy. What if I, let's say, do do do. Okay, strategy, strategy. I will transform. As transform is a big word. I'll just turn uh partition line, turn partition lines into slots. So how many partitions lines are there? There are two partition lines, right? And there are three slots. So now we take the number of slots plus the number of partition lines, all right? And in this situation, we get 5 new slots. I should name it maybe uh how do I change the name? What's the new name I'm looking for a new slot? Maybe 5 sections. Yeah, 5 sections. Okay, 5 sections. So now we have 5 sections. All right. So here, 1, 2, 3, 4, 5. See, now I have 5 sections. Okay, 5 sections. So uh, now maybe for each section, I can assign a microstate. All right. So for each, let me just put this over here. Okay, so for each section, uh, I will assign a unique microstate. Okay, yeah, it's like if I have if I have a section function s of q, all right, and I can assign for every s of q, I can assign a unique microstate, right? A unique microstate. Okay, and I will give an example, which is this one. So here I have 5. You can see 5 cells here. 1, 2, 3, 4, 5. And let's have an example. Let's say I have A, B, C. A, B, C. Okay, so what does this equate to? It's for what microstate? This is for the, okay, I should draw. This is a microstate that we have. The slots, the microstate for, okay, three slots here. So this equates to ABC that belongs in the same slot or slot number 1. All right, and the rest has 0. Okay, right. Slot number 3. There we go. Okay. Now I hope that you know what's about to happen here. Okay, let's have another example. Okay, another example, we have what? Let's say we have A over here and BC over here. Okay. Now what does this equate to? This equate to A and then BC. Right? Because there is an empty space. There's an empty section between A and BC. All right. So A and BC must be in different slots. Now B is next to C, which means that B and C must belong in the same slot. So now we have established a rule for this. Um, if next to each other, to or let's say let's put it in technical terms. So we have adjacent 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 section means same slot. Okay, they belong in the same slot. For example, in this case, ABC, they are in adjacent sections, so they belong in the same slot. All right. If not, they belong in different slot. All right, here. So separated for if the length of separation is 1, then it's different slot. Different slot. Right. For example, in this case, uh, there's an empty slot between A and BC. So A is in slot number 1 and BC is in slot number 2. Why isn't BC in slot number 3? Because there's an empty section at the end. So this empty section is for slot number 3. Okay. Okay, I'll give another example. Okay, another example. This example then. So in this case, let's have BC over here. BC over here, which means that this is a empty slot, BC, which means that BC is over here. And there's no one here. There's no one in slot number 2. Okay, so that's what it means. Alright? Because why? There are 2 separated slots in between A and BC. Alright? So the difference must be 2, which means that the slot number 2 must have no one in it. Alright? Right? So separation by 1 section. So separation by 1 section means what? Means adjacent slot. All right, and separation by 2 sections. In this case, we have two empty sections here. Then what does that mean? It means separated by 1 slot, right? Because in this microstate, slot number 1 has A, and then slot number 2 has no one. Okay, separated by 1 slot, and then slot number 3 has BC. All right. Okay. I think you know where this is going. Okay. So let's give another example. Right? Let's say we have oops, didn't mean to do that. Let's say we have A, okay, separated by 1 section, B separated by 1 section, C. Alright, so let's read the rule book. Okay, this is our rule book. This is the rule book right here. Alright, that's the rule book that we have. Alright, so let's take a look at the rule book. Okay, so separated by 1 section. What does that mean? Adjacent slot. So what it means that A will be here, B will be here, and C will be here. Done. Alright. Alright, so if you continue this pattern, you know what's going on, which means that for n slots and q people, right? For n slots and q people, there will be how many sections? There will be the number of sections will equal to the number of people plus the number of slots minus 1. Because for every q people, there are n minus 1 slots. Alright? Okay. Okay, yep, I think this makes sense. Yeah, that makes sense. Or for every n minus 1 slots, there'll be q people. So q plus n minus 1. Alright? So okay, so now we have figured out the number of sections. So now if you take a look at the sections here in this case of 5 sections, if you take a look at each one, it's really like asking how many ways are there to assign 3 people into five sections. All right. So how many ways are there to assign three people, in this case ABC, into five slots, five sections. Sorry, the number of sections, five sections. All right, and when you are dealing with n slots and q people, then the questions you're really asking in order to solve this puzzle is how many ways are there to assign q people, all right? Q people into how many sections? Q plus n minus 1 sections. And the answer to that question is obviously combinatorics. We have Q plus n minus 1, choose Q, right? And let's say this is our function omega nq, all right? Yeah, that's just a function that if you give me n slots and q people, this is the way to assign q people into q plus n minus 1 sections, all right? And the and to expand that, then if you remember the formula from ninth grade or from your high school, it's q plus n minus 1 factorial divided by q factorial multiply n minus 1 factorial, and that is the answer. Dum, 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 ba-bum. We're done. It's a good problem, very good problem. And I would like to say, uh, I thought of this problem from the thermal physics book by Schroder, I think Daniel Schroder. Uh, and if you're interested, you should read the book, Introduction to Thermal Physics by Daniel Schroder, and you will see this formula from section 2.2, which is about the Einsteinian solid. Okay? And yep, we're done. Bye bye.